Good evening. For this programme, we're going to go right out to the edge of our known solar system. Beyond Jupiter and Saturn, there are two more giant planets, Uranus and Neptune. We call them the ice giants, because they're very different from the two gas giants, Jupiter and Saturn. With me, two experts, both from Oxford, Dr. Lee Fletcher and Chris Linthorpe. Can I have first you, Lee? So what are the main differences between the ice giants and the gas giants?
In fact, we knew very little about the ice giants before Voyager 2 flew past in the late 1980s. Voyager flew past Uranus and saw a greenish disk with very little cloud activity taking place over the disk itself.
It was a really boring planet, let's be honest about this.
Well, lots of scientists looked at it and were quite disappointed. We were used to Jupiter and Saturn and seeing incredible storms and banded systems.
You didn't see storms and rings there.
We saw
there, but we didn't see them.
And in fact, that's been revealed over the last 25 years since Voyager 2, is that we've got a large data set of Hubble Space Telescope and ground-based observations of Uranus, which show that we simply flew past at a rather boring time. And in fact, it's become a lot more active now with white spots, incredible collars around the North Pole and the South Pole.
Uranus and Neptune are twins. They're dissimilar twins. Why?
Well, Voyager 2, when it flew past Uranus, gave us an idea what we thought an ice giant should be like. When we got out to Neptune, we realised that those ideas were again wrong, because Neptune has its own source of internal heat. It emits out more energy than it's receiving from the sun. And that emission of heat is driving a really complicated weather pattern. We see incredible storms, such as the Great Dark Spot that was present in Neptune when Voyager 2 flew past in 1989.
But we haven't got that with Uranus. Apparently there's little or no source of internal heat. Why not?
Well, this has got something to do with the dim, distant past of our solar system and the way in which the ice giants formed in the first place. Something back in Uranus's distant history must have changed the planet into its present inclination.
Because it's really weird.
It's extremely strange.
We haven't mentioned that yet.
And what we should say is that Uranus somehow has been tilted completely over on its side.
Exactly.
Now, the Earth and Neptune, in fact, have a tilt of about 23 degrees, 26 degrees for Neptune.
So if this is the Sun and this is the Earth, then you orbit...
It means that the planet is rotating like this. Right. So it suffers from spring, summer, autumn and winter in the same way as the Earth does. Uranus, on the other hand, has got such an extreme tilt that it spends many, many years with just one pole of the planet facing towards the Sun. And in fact, when we flew past in 1986, the south pole of Uranus was pointing straight back towards the Sun.
What do you mean by the South Pole?
The South Pole has been defined by the International Astronomical Union as being the pole which we flew past.
Yes, so stop being awkward. The point, another point.
Point taken.
There's another critical point here as well. So if this is our Uranus and the planet's spinning like this, all the moons are in line with that axis as well. So why do people think this has tilted?
It can't be invalid, surely.
Well, one of the most popular theories out there today is that something in the distant past hit Uranus.
A large impact, in fact.
Some kind of large impact.
Where is it now?
Where the impact would have melded the two planets together such that what we see as Uranus today is the agglomeration of multiple impacting bodies.
You don't sound convinced.
I'm not.
So how would you do it? How do you tilt Uranus?
I wonder the age of planetary migration, interaction with Uranus and the other giants, and gradually tilted it over.
Well, during the migrational period, there is a very good chance that collisions of this sort were happening. In fact, the motions of these planets is causing gravitational instabilities, and it's flinging material around all over the place.
So I have a silly question, which you were talking earlier about ice giants, Patrick, but we're not looking at ice, we're looking at gas.
Oh, of course.
So why do we call them ice giants? Why aren't they just more gas giants?
Because they're icy.
Well, yes, but where's the ice?
It's an important point, and it does confuse a lot of people. The reason we call these things ice giants is because the material that they're actually made of, planetary scientists call ices. So these are things like methane, things like ammonia, and things like water that have condensed to form solids in the outer solar system. Now, these have all been incorporated into the interiors of these two ice giants, but even then, they're not ices as you would imagine water ice being.
But if I plunged through the atmosphere and stayed alive, would I hit a solid icy surface?
You won't hit solid surfaces. What you'll see is that these ices are slowly being pressure cooked. the pressure is so immense at the centres of these giant planets that the ices take on a very alien and exotic form. Okay, now in Jupiter and Saturn, it's hydrogen and helium which consists most of the bulk of these planets. And hydrogen takes on something called a metallic form. Yeah. And this metallic form is conducting, and that's where we believe we get the magnetic field of the giant planets from. Now on Uranus and Neptune, there isn't as much hydrogen and helium because there simply wasn't as much available in the outer disk when it formed. So the thing that gets pressure cooked are these ices that you're talking about. And those ices that are in a sort of molten fluid state within the interior, they are still conducting. So Uranus and Neptune do have magnetic fields, but even those are extremely odd. They're tilted and they're offset. There's a lot that we simply don't know about them.
It occurs to me, I mean, we talked about the Great Dark Spot a bit, and you now tell me that Uranus is interesting again. I know I've been abusing Uranus, so maybe I should stop being cruel to it.
So over the last quarter century, since we flew past with Voyager 2, Uranus, which was dull and bland at the beginning, seems to have taken on a more Neptune-like appearance. And by that I mean it's become a lot more active.
So it must now be, what, autumn or spring on different bits of Uranus, right?
So the north pole of Uranus is slowly coming into sunlight for the first time in 40 years.
So
it takes 80 years to go round, so it's springtime in the northern hemisphere. And that means that suddenly you've got energy being deposited from the sun into Uranus's atmosphere, which is triggering all this fantastic weather-like systems. And that's why I believe we must ultimately send another spacecraft back to Uranus, other than Voyager 2. Voyager 2 flew past so quickly, it gave us just a snapshot of the dynamics and the chemistry.
Uranus orbiter.
We would love to see something go into orbit around Uranus to explore the moons and to explore the rings of Uranus and the atmosphere and interior. But I think that the big step change in our understanding of ice giants in general would be if we were to send a probe into Uranus. Now, we did this once with Jupiter back in 1995. The Galileo probe went in and sampled the gases and figured out what the chemical makeup of Jupiter was. But if we did that for an ice giant as well, it'd be a wonderful advance for our science.
Both Uranus and Neptune have rings and satellites. Well, what about them?
Now, I think the most interesting out of all of the Uranus and Neptunian moons is a moon called Triton. Now, Triton is a big moon in orbit around Neptune.
Not a genuine moon, though.
But it's not a genuine moon. No. By that we mean that instead of forming from the same disk that Neptune formed from, it looks like it's been captured by Neptune's gravitational pull.
And we know that because it's going backwards.
That's right, it's going in a different direction to all of the other moons in the system. Now,
very like Pluto, probably.
That's right. In fact, the surfaces of both Pluto and Triton, I mean, if they did form in the same place, this shouldn't be a surprise. They're covered in surfaces of nitrogen and possibly methane and carbon monoxide condensed onto the surface. Now, the interesting thing about that is that when Pluto and Triton, when they get close to the sun's energy heats them up and it causes these things to sublimate off. Basically, they form a gas which goes into forming a very, very thin, tenuous atmosphere around these moons. And the last thing to say about Triton is that with Voyager's flyby, we actually saw active geysers on the moon itself. And that makes Triton one of the most interesting places in our solar system in having some sort of volcanic activity. Now, who'd have thought it for something so far away?
It's a bit like the moon is being flexed by the gravity of Neptune, I would
In fact,
assume.
what they saw with the geysers themselves was that most of the geysers were clustered around the point at which the sun's energy was the greatest. So it looks like the influence of solar radiation has some effect on destabilising the surface. And that's why you see these amazing plumes in the old Voyager movies.
Well, we've come a long way, and thank you both very much. Uranus was discovered in 1781 by William Herschel for the Herschel Museum in Bath, and Paul Abel went there.
The Herschel Museum is in the heart of Bath, and this beautiful Georgian house was once home to the great William Herschel and his sister Caroline. German-born Herschel arrived in England fleeing the Prussian War. He was penniless and made the spa town of Bath his home, earning his living teaching young ladies music. He brought over his sister Caroline to run his household, and together they became two of our greatest astronomers. Well, this is Herschel's piano because he was first a musician, then he became a rather prominent astronomer. And look at this is brilliant. This is a picture of the distinguished men of science of Great Britain living in the year 1807, and there's Herschel, right on the end. Wandering through the museum, you really feel Herschel's passion for astronomy. These are his original telescope eyepieces. Just think, Herschel would have looked through these to map the night sky. Herschel also made his own mirrors, striving to improve the magnification so he could see further into the heavens. Well, here we are in Herschel's workshop, and it's here that he made the telescope mirrors, not just for himself, but for other astronomers as well. And back then, of course, telescope mirrors were made of metal, and he'd take the blank, put it in this device, and spend many, many hours polishing the mirror until it gained the desired shape. And it's here that he made the telescope mirror for his famous 7-foot telescope, which is upstairs, the one which he used to discover Uranus. So let's go upstairs and take a look. Herschel was eventually to become famous for his enormous 40-foot telescope in Slough, but in Bath he had a more modest reflector. Well, here it is, a replica of the 7-foot telescope used by Herschel to discover the planet Uranus. And in doing so, he became the first person in human history to discover the existence of another large planet far beyond the orbit of Saturn, thus opening up the icy depths of the solar system to us. With the discovery of Uranus, the Herschels became overnight 18th century celebrities. The King and many others came calling. Jonathan Hall is one of the resident astronomers helping to promote and preserve the work of William and his sister Caroline. Back in the 18th century, Herschel's nighttime activities were viewed by the good people of Bath as unusual.
His local reputation as being a little bit eccentric and very keen on the sciences and mathematics and optics, he would actually set his early telescopes up in the street, and the horse and carriages, of course, were obliged to go around him. He wasn't what today we might think of as a professional scientist. He was purely amateur, and he was building these telescopes with the aid of his brother and local craftsmen to arguably the best standard of the time.
Yes, and he made mirrors for many other people as well, many other prominent astronomers.
He did indeed, yes. Even in his youth, he started to read books on astronomy, read books on optics. He'd been teaching himself a little bit of Greek. He taught himself Italian and Latin, partly because of his music interests as well.
So much self-taught.
Incredible, yes, very tenacious. But it was really when he came to Bath that it really started to take off.
This is how the night sky would have looked on March the 13th, 1781. In the constellation of Gemini, there was an object which other eminent astronomers, such as Flamsteed and even Galileo, had overlooked. Herschel immediately knew that this was something special.
He wasn't actually looking for a planet. He'd only just moved back into the house. They'd been in a previous property. And in fact, rather unusually, he was on his own. Because
Caroline normally observed with him.
Absolutely. And he set the telescope up here in the garden, doing the systematic review of the heavens, and there trained it on the constellation of Gemini, and that's where he made the discovery.
And that brand new world needed to be named.
It did indeed.
So for a long time, people wanted to call it Herschel.
Yes.
He wanted to name it after his patron, didn't he, King George III? So in a lot of the old texts at the time, you can find it listed as Georgius Sidnus.
Well, that's right, yes. I mean, Herschel, of course, was no fool.
No.
Patronage in those days, of course, was immensely important. Yeah. And the other link, of course, is that King George III, part of the Hanoverian Empire, Herschel was from Hanover. So as part of the patronage, the king created a brand new post for him. He had to leave his life here in Bath, so he could be at the beck and call of the king and the royal family to actually then be able to go and show them the wonders of the heavens. And it's quite remarkable, over the 2 or 3 years immediately following discovery, all the eminent people from really literally around the world and from Europe who would actually come and pay homage and pay their respects and want to look, of course, through a Herschelian telescope.
Yeah. The planet was eventually named Uranus, which in Greek mythology is the father of Saturn. It's in our night sky at the moment, in the constellation of Pisces the Fishes. It took some time to find it, but I made this drawing of it the other night. Herschel discovered this strange world over 200 years ago. It changed his life forever and guaranteed him a place in astronomical history.
Well, the Herschel Museum, well worth a visit, I can assure you, if you're in Bath.
Patrick, Herschel always makes me think of you, because of course he was a musician and an astronomer as well. And you've played some of Herschel's music, right?
I'm a very amateur musician. I've never had a lesson in my life, but we did a program about Herschel once, and I borrowed some of his music and played it on the air live on the piano.
Was it any good?
His music is.
Good. I wasn't asking about your piano playing.
I got through it. We've gone a long way now, so let's go even further out of the solar system and come to the Kuiper Belt, of which the most best-known member is, of course, Pluto.
Pluto is a very similar object to Triton in that it has over the surface ices of things like nitrogen and carbon monoxide that over the course of Pluto's extremely long orbit around the Sun will sublimate off to form a kind of atmosphere.
When it was discovered by my old friend Clyde Tombaugh, it was thought to be at least the size of Mars, probably larger, and therefore of planetary status. And we regarded it as a planet, and only has it been demoted.
It's been demoted, that's true, but I'm not sure it's particularly because Pluto's smaller than we thought. It is, it's smaller than Mercury, but it's more that we found lots of other things this size out there.
It's not the only one.
It's not the only one, so we had the choice of having 8 planets, as we do, from Mercury out to Neptune, or many, many, many planets. And we call those the Kuiper Belt, and Pluto-like objects are one part of it. Of course, the most exciting thing about Pluto is that there's a spacecraft on the way. New Horizons, which was planned, not that it matters, but it was planned while Pluto was still a planet, and a big part of their pitch was this was the last planet that we haven't seen.
Quite.
But where's New Horizons got to now? It's a few years away yet.
So it's still on its way to Pluto. It's going to get there in July of 2015, and it's just got past the orbit of Uranus. Now, it doesn't mean it visited Uranus, but it's on its way to do a slingshot by Pluto. And after Pluto, it's going to go on to look at another Kuiper Belt object.
Which hasn't been discovered yet.
No, it's something that we're still looking for at the moment as to where to go.
Right. Well, Pluto is interesting. It's merely the brightest member of the Kuiper Belt. It's certainly nothing more than that. There are plenty of others. And recently there was a big conference in France about these things. And Dr. Chris North went there and brings back news from the Kuiper Belt.
This year's annual gathering of planetary scientists in Nantes was the largest for many years. For space scientists, it's a great place to talk about missions to the planets, and for the astronomers, a platform to launch their new ideas. This year, the icy dark depths of our solar system have caused a bit of a stir. The Kuiper Belt stretches beyond Neptune and has previously been dismissed as the dustbin of the solar system, the leftovers of its formation. Meg Schwamb has been raking through the rubbish to find clues about the Kuiper Belt and its formation. We now know that there are lots of exotic objects out there. They come in a range of sizes, and some, such as Pluto, even have moons. While many formed in these icy outer depths, others formed closer in and were flung out there by the movement of the giant planets.
The Kuiper Belt really is the icy remnants left over from planet formation. You can think of it as the embryos and the failed planets that didn't form into the terrestrial planets or the cores of the giant planets and have been scattered out or may have formed out in orbits beyond Neptune. And so Pluto is one of the well-known and largest of these objects, and there are now many Pluto-sized bodies known in this region, as well as many hundreds of thousands of other smaller bodies that orbit in orbits well beyond Neptune.
In 2007, Meg discovered an object nicknamed Snow White, one of the largest Kuiper Belt objects at around half the size of Pluto. Despite its name, Snow White is actually red. The colour is caused by a tarry gloop called tholins, a term coined by Carl Sagan. We think tholins are methane and other chemicals broken down by weak sunlight over billions of years.
I mean, I don't think we've quite touched tholins in the outer solar system, but we think it's that if you take these methane ices and nitrogen ices, and you keep irradiating the methane, you get higher and higher order hydrocarbons, and so you get more gunk and tar. Right. And so that's what we think it is, and we think it's reddened their surface, and so it's sort of this red crust or radiation crust sitting on the surface.
It's goo.
It's goo. It's sort of, yeah.
It comes from the Greek word for muddy, I believe.
I believe so, yes.
Kuiper Belt objects are the preserved remnants of our early solar system, and they tell us what it was like billions of years ago when the planets were forming. But studying it can be very frustrating, as the objects are so small and so very far away. Occasionally, however, we get visitors from the outer limits. Comets. Mike Ahern has led one of the most successful missions to not one, but two comets. In July 2005, part of the Deep Impact probe was smashed into Comet Tempel 1, giving us our first view of material from inside a comet. Following this successful mission, the Deep Impact spacecraft was rerouted, and in November 2010, flew past Comet Hartley 2, where it saw a very different world.
Every comet we've visited has been very different from what we would have predicted from the previous one we visited. So that's the reason for going to multiple ones, to try to find a pattern. One difference between Tempel 1 and Hartley 2, the two that Deep Impact spacecraft visited, is they're very different sizes and very different activity for their size. On Tempel 1, we saw differences in the outgassing from different parts of the comet. Now, does this mean different parts of the comet came from different parts of the protoplanetary disk? It was hard to tell because
so
there was
made of different stuff.
But there are strong seasonal effects on Tempel 1. Now at Hartley 2, it's in this excited state rotation where in addition to going around like this, it rolls, so everything gets illuminated all the time and there are no strong seasonal effects. And we still see big differences between the outgassing at the two ends, which says that they really must have come in the early solar system from different distances from the sun.
So they are different.
They really are different.
Comets, the archaeological remains of our early solar system, will help us understand how the planet Earth became such a unique world.
It's important because, for one thing, we think the comets bring all the water to Earth, or at least some of us have thought that all along.
Is that just because Earth's the only planet we know of with standing water on its surface?
Yes.
And the early Earth, that should have all boiled off, essentially.
Exactly.
So
exactly.
Where did it all come
So
from?
it has to have been brought in at a somewhat later stage, for only 500 million years after the formation. But
a long time ago. Yeah. The Kuiper Belt is clearly not the dustbin of the solar system, and the exotic objects that live there are far more than just rubbish thrown out during its formation. Instead, each one is a fascinating world, and the more we find out about them, the more we find out about our own origins.
Well, 10 new nights this month, so we'll go out now to Chris North from France and of course Chris Lindhop. Well, huge storm going on Saturn.
Well, a huge storm that's been going on for most of the last year that was discovered last December as this white spot, which is the form storms on Saturn normally take. But then this one spread out until it covered quite a lot of the disk.
A huge thing.
You can see it in these new images that we've just got from Cassini, though they were taken over the last year. And of course the amateurs saw this as well. And then they saw the storm fade over time, and it seemed like all was quiet on Saturn. But if you talk to the professionals who can use some really big telescopes and they can look in the infrared, they see that actually what's happened is up in the top of Saturn's atmosphere, up in what would be the stratosphere, there's still a lot going on. The storm now covers about a quarter of the disk, so all of the northern bit you can see on one side of the disk. But as it emerges in January, I think we're going to see some really interesting things happening where this storm was last year.
I wonder what we'll see.
Well, we'll find out.
Well, coming into Jupiter, and the second moon there, Europa. Interesting news.
Well, Europa is this moon that's got the very weird terrain. We call it chaotic terrain. And it was terrain that the Voyager probes in Galileo saw, covered in cracks and fissures and all sorts.
Mapmaker's nightmare.
Yeah, indeed, a mapmaker's complete nightmare. And what we think is happening still is that that's cracked and broken up by the motion of a subsurface ocean beneath the icy crust. We can compare that to stuff we see on the Earth. And some of the features look like things we see in Antarctica with a subsurface sea, a subsurface lake, that's not quite that deep.
People are excited about this because it's always been my favourite idea for a mission anywhere in the solar system, which is you land on Europa and you melt your way through the surface, and then you see something with teeth coming towards you. Because the reason people care about this ocean is it's an interesting place to think about life.
It could well be.
Life on Earth, we think, started in deep oceans without much sunlight. So Europa's a fascinating world.
They all are. Well, of course, you can't get away from Mars. Always something new there. And of course, this new probe, Phobos Grunt.
Yes, this was a Russian probe that was meant to go to the Mars's moon Phobos, collect a sample return mission, bring it back to Earth. Unfortunately, it made it into orbit. It's been stuck there. It's not sure what will happen, which is very sad. Amazing.
The Russians have never had any success there.
It was incredibly ambitious. It would have been the first sample return mission. But we shouldn't forget there's good news for Mars this month as well, which is that the American Curiosity rover is successfully on its way.
Liftoff of the Atlas V with Curiosity.
We're going to find out a huge amount about Mars's past and about whether there are the conditions for life there. So I'm really excited about Curiosity.
So far, all goes well.
We have spacecraft separation.
One more new note. We found a long-lost Sky at Night program on a recording machine, and here it is.
Now, I'm talking about moon bases tonight for two reasons. First, because they are very topical, and we've just shown you one new design study. But secondly, because I'm delighted to have with me my old friend Arthur Clarke. Now, Arthur, you, of course, were forecasting developments of this kind, more than 20 years ago.
Well, thank you, Pat. And I'd like to begin with a flashback to the communications satellite which you mentioned by showing this illustration, which is of some sentimental interest to me, because I displayed this on BBC TV about 10 years ago. And this was undoubtedly the first time that anything about communication satellites appeared on TV anywhere in the world.
So, I mean, this is a programme from 1963, and to put us in context, that was before Apollo. Apollo was still in the planning. We'd had people into space, but only a few probes whizzing past the moon. And, I mean, Arthur C. Clarke was predicting not only these communication satellites, which were then starting to become a reality back then, but also was talking about bases on the moon, bases on Mars, all incredibly exciting for what we might do from then in the next sort of 20, 30 years.
Well, I think a great deal has depended there upon the question of the lunar atmosphere, because if the moon had proved to have anything of an atmosphere, then of course the surface dome would have been the answer. Do you think that this means that the lunar base has got to go underground?
Well, if it turns out that a meteor bombardment is a serious danger, then undoubtedly we will have to put our bases underground. But I rather hope that the necessity of a lunar underground movement does not arise. I hope we can stay on the surface and look at the stars.
So do I.
He and I are great friends. This is one of the few recordings we made together that's actually been preserved.
Yes, it's wonderful to see it again. I think if you could have picked one Sky at Night out of those that were lost, I think this one would have been high on the list.
I would agree.
Well, you can see more clips from it on the website, which is bbc.co.uk/Sky at Night, and I'm certainly going to go and watch it again and dream of Mars bases.
Well, thank you both very much indeed. When I come back next month, we're going even further and look at planets of other stars. Until then, good night.
Horizon is Seeing Stars with a look at technological advances in stargazing, and that's over on BBC 4 now. Here on BBC HD, stay with us for MasterChef The Professionals.